Before we learn about how to graph a parabola, let's figure out exactly what they are. If you have a right circular cone, like this, and we have it intersect a plane like this, the intersecting parts of these two objects would represent what exactly a parabola is. Whenever you intersect a plane with a right circular cone, the intersecting area is called a parabola, as shown in the red dotted line. In this lesson, we're going to graph a parabola by completing the square. This equation right here is called a quadratic equation because the power of the x is 2. Keep in mind that some quadratic equations only have one variable, such as x squared minus 4x plus 2 equals 0. Those particular quadratic equations cannot be graphed, but the ones that have the y and the x in it can be graphed. A simple way to graph these would be to put a value in for x and then solve for y. For example, if x equals 0, y would equal 2. So your first point would be 0, 2. And then you would continue on with that process and put in another value in for x, such as x equals 2, then solve for y. That'll be your next point. You keep doing that until you have 2 or 3 points, then you could put them on a graph, and then you could draw your parabola. But the one that we are going to learn today is completing the square to graph this particular quadratic equation. Parabolas can be either facing up or facing downward. And every parabola has what they call an axis of symmetry. That's in the blue line. So everything is symmetric around this blue line. And at this point, you can ask yourself, is this graph an upward or downward graph? It's going to be one or the other. And the way to figure that out is to look at the coefficient of the x right here. And the coefficient of the x is a 1, which means it's a positive number. And if it's positive, the graph will point upwards, as this particular one here is. If it's a negative number, like a negative 2x squared, then your graph, your parabola, will graph in a downward fashion like this. Another interesting thing that you can learn about this particular quadratic equation is this 2 right here. The 2 is called the constant, and that tells you where this particular parabola is going to hit the y-axis. So here is a coordinate grid, and I'm going to go ahead and put a spot where we know that this particular quadratic equation, this parabola, will hit the y-axis, which is the vertical axis that goes up and down here. So right there I entered the point where this particular parabola hits the y-axis at 0, 2 on the coordinate plane. So there are several things that you could figure out by looking at a quadratic equation that needs to be graphed as a parabola, whether it's going to be upward or downward, where it touches the y-axis, just by looking at the actual equation itself. In order to complete the square, we're going to want to rearrange this quadratic equation into this format here. Y equals the quantity, x plus a squared, plus the constant, which is the 2, by the way. As I complete the square, I'm going to place parentheses around the x squared term and the x term as noted there. And now to the left of the screen in red, you will note that in order to make this expression in the parentheses a perfect square, you need to take the coefficient of the x, which is 4, a negative 4. You need to multiply that times 1/2 and take the square of that, which is actually 4. So I'm going to put that right here, plus 4. And as we add our perfect square, the plus 4, inside the parentheses, we need to balance it out by subtracting 4 from the constant right there. And that equation simplifies to y equals a quantity x minus 2 squared minus 2. Again, there are several things to look at. Number one, we have a plus in front of here in red. That tells you that the parabola opens upward. We know that immediately from that. We can also tell the axis of symmetry, which we talked about earlier, is derived by looking at the inside of the square, the negative 2. We know that the axis of symmetry is x equals 2, which I drew in red on the graph. And by looking at this negative 2 here, we know that the y-coordinate of the vertex is a negative 2. So therefore, shown in red on the graph is the vertex of this particular parabola. So at this point, we have 2 points that we can start drawing your parabola with. The 0, 2 right on the y-axis, the negative 2 point of the vertex. And since this parabola is symmetric around the vertical x equals 2, we know that the other point is symmetric would be 4, 2, as now shown in the graph. So if I were to graph this parabola, it would look something like that. So this is how you graph a parabola by completing the square.